Today's lesson is about polynomial. First, what is polynomial? Polynomial is an expression where we can have the variable with the exponents, addition, subtraction, multiplications. We can have a division of the number but not the variable. Okay, so what is not polynomial? So for example, polynomial, we can have something like this. That is polynomial. Okay. So what is not allowed or what is not polynomial? So we're not allowed to have um, the negative exponent of the variable. For example, we are not allowed to have something like that. Okay, that has a negative 2. We're not allowed to have uh, the um, the radical. We're not allowed to have um, the fractions, exponents, and we're not allowed to have um, the variable on the denominator like this. So at any time you have those on an expression, they are not polynomial. Yes. So move on to the next question. What is the degree of a polynomial? So the degree is the highest exponent of the variable. So for example, we have so now for 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 these expressions we want to find the degree. So stick to the definitions. We need to look for the variable with the highest degree. So now we have the variable x here, right there, and it's right here. And this r is exponent. This has exponent of 1. It has an exponent of 4. So the degree of this expression is 4. So now we need to get used to the habit of rearrange the expressions and keep them in order from the highest degree to the lowest degree to a constant. Okay, so we need to rearrange this. We cannot keep it like this. Okay, we're going to make a mistake later on. So we have to move the 3x to the fourth power because it has the highest exponent degree. And then the 2x to the third power is next, and then x to the first power, and then we have this. So make sure anytime you have an expression that not in order of the degree, you have to put them in order. Okay, so how many solution this expression has? So basis on the degree. So we want to answer the question, how many solutions? So it just the question asks how many. It does not ask what are the solutions. So basis on the degree of this function, we we can call this function f of x. So basis on the degree. All I know is has the most. Okay, it has the most four solutions. So whatever whatever the degree of the function is, that will be the most solution you can have. So we can try. So let's graph. So let's graph instead of -5, let's graph +5. On Desmos, we're going to see the two x-intercept. One is -0.9 and one is 1.4. So those are the so these two are the two solutions to this functions. It cannot have more than four solutions. So in general, so so in general, sometime that we can use the graph and be able to tell what's the degree of the function is. For example, if I have a parabola like this, okay, so how many solution this one should have? So it has the most two. So how do we know that? So we can use this we call the volley. So it has two solutions here. So anytime you have a volley and a hill, you add them up together, you plus one. That's going to give you the degree of the functions. So let's see another example. If you have something like this, you have a graph like that. Okay. So what is the degree of this? So we want to see how many hill and volley. So this is the hill, this is the volley. So we add in the hill and the volley together. We got 1 plus 1, which is 2. And then we need to add one more. That's going to give you the degree of the functions. So let me give you another example by, by using the graph. So let's say we have a graph look like that. We want to know what is the degree of this graph. Okay, so now we need to find how many hill and how many volley. So this is one hill. So when it's go up and down like this, and when it's go down and up. So this is a volley. This is the volley. So we have total of three hill and volley combined. So the degree of this graph is 4. So let's move on to, let's summarize the end behavior by using the table. So let's say I have the table like this. Let's draw one more over here. So this is going to be an even degree. So let's say we have x2, x to the second power, x to the 4, x to the 6, and so forth. Down here we have odd degree. Let's say we have x to the third power, x to the fifth, and so forth. Over here we would have the positive leading coefficient. So what is the leading coefficient? Let's put it down here. So the leading coefficient is a number that go with, it's a number that goes with uh, in front of the degree. So for example, that if we have a negative 3x4 plus 5x minus 2, for example, so the leading coefficient is a negative 3. So that's what the leading coefficient is. So there should be only one leading coefficient. There are many different numbers on this expression, but there should be only one leading coefficient. So let's go back to the table. Now on this side, of course, we're going to have a negative leading coefficient. So now when the graph, so what's the graph of the even degree with a positive leading coefficient look like? It always going to look like, it always going to look like this. So we don't care what the middle part of the graph is. It always going to look like that. So what is the end behavior look like? So end behavior of x to negative infinity, where is this end going? This is the negative, so this is negative infinity sign, and this is positive infinity end, okay, according to the x-axis, okay? So now we're going to have y going to positive infinity. So what about if x going to positive infinity, as you can see this end over here also go to positive infinity. What happened to the negative when the function has the negative leading coefficient? The graph will not look like this. So it's facing down. Then we would have the end behavior when x to negative infinity, the functions also go to the negative infinity because it's going down. It's going down. So if x going to positive infinity, the function's going to negative infinity because it's also going down to the end. So remember the end behavior is where this two end of the graph is going. What about odd degree? Odd degree with positive leading coefficients always gonna look like something like this. For this graph, the end behavior should be like this. If x to negative infinity, remember if end behavior to the left is going to negative infinity, the function's going to negative infinity. And if x going to positive infinity, the y going to positive infinity. So as x going to negative infinity, the function's going to positive infinity. That's the arrow. And then x going to positive infinity. This y going to negative infinity.